In this recording in our series on face milling operations, we will take a look at the different ways to create geometries. If we go into our face mill operation, you'll note that up until this point, we've always used the option of stock-based boundary. That's because we always want to remove all the stock that's on top of the part. But what if we have a different case? For example, if we take a look at this part, this is a very large part where a good bulk of the area does not really need to be cleaned out with a face mill because I may be doing a pocket type of operation to clean out these areas over here in any case. So it will be a waste of time to have the face mill go over those areas as well. So what we can do is we have the other option here called part-based boundary. Now let's take a look at what the options actually are. If I click on it, it'll give you a geometry by default, which is a boundary around the part. But I can create new geometries. If I go in there, as default, it gives you model, and if I base it on the model, it's exactly what I told you what it was before. I can go down here, take the target, and I'll just create a boundary around the target. That's not what I want, however, this time. I want the option of faces. There's also an option called profile that's basically building a chain geometry around the part. I'm going to take the option of faces, and then I'll go further down. We have base geometry. If I click on define, I'll just click on the faces that I want to work on. I want to work on this face. I want to work on this face, and this face. Those four faces. And you can see them also right here. By the way, I could have also defined them with a particular color and just pick all the faces that are a specific color. Okay, I just use these right now. I'll click on OK. Now, you'll note it looks like you really have a boundary around the entire part. That's because what it does is it combines everything together into one boundary. However, we have the option to separate them. If I click on separate, now you'll see we have four different chains around each one of those surfaces. I'll accept that. I'll take the face mill that I want to use. In this particular case, the face mill has a 70 millimeter tip diameter, which is enough for what I need. The levels, I'm just going to leave it exactly the way it is. It's default. And in technology, I want to use one pass, where it's going to take one pass over each one of those faces. Now, let's just go down quickly to links. As default here, it gave me a tangent, but I can leave it at none. And I'm just going to do save and calculate. Let's take a quick look at what the results of this are. I'll run my simulation, and you'll see that the first pass goes over that first area. You'll note, by the way, this area is empty because I had already did a pocket operation over there. Now, when it finishes that one pass, it goes back to the next one. This area over here goes down and across, now goes to the next area and back to these areas over here as well. And then it's done. It should be noted that when it goes from one area to the next area, it uses the rapid motion above the part, so making it a really fast movement.